afternoon, everybody. Great to see so many people. That gives at least a good feeling that we're moving in the right direction, because we have a lot of work to do to make textile circular. Before I dive into the presentation, I'll briefly explain something about myself, so you know a little bit of the context. My name is Josse, chemical engineer by training. Have been working for a very long time for DSM in various roles, often fiber related. Started for myself a couple of years ago, a company called Kidawara, which means small circles in Swahili. It's around how do you organize an industry in, let's say, a 300-kilometer range without shipping your waste to China or something like that. So taking full responsibility. Out of my own company, I work for polyester as Chief Commercial Officer for CuRe Technology, also a shareholder of CuRe. I also advise Italian company Aquafil, but then on nylon 6. Scouting effect for technologies for them to get more feedstock because they have an existing chemical recycling of polyamide 6. And they also have a startup, they will do a pitch tomorrow, where we use bio-based polymers to make durable goods. So a couple of different things. Now let's see if technology works, because now I should go to the next slide. Yes, very good. I guess most of you are aware, but polyester is the largest synthetic fiber in clothing, in textiles, also still growing. And if you amount that together, it's about 50 billion kilograms of new fibers we put into the market every year. 50 billion kilograms. That's about 2/3 of all the polyester we make. Now, overall polyester is about 9% recycled, but that is almost 100% of that recycled is transparent polyester from bottles. There is less than 1% of the textile being recycled. So as an entrepreneur, I see a huge opportunity, but as society, oh boy, we made our life a little bit difficult. We really need to solve this. We need to get rid of fossil resources as a feedstock. We need to use used polyester as a feedstock. So that's what we're trying to do at CuRe. Yeah, there we go. A lot of people ask us, can we already ship you pallets of product? And I have to say, sorry, we are on a journey. We are developing this. And we are on a journey already since 2018, when we formed the first consortium. I'll later share with you who the partners are in CuRe. We've built a very exciting pilot plant in Emmen, in the northeast of the Netherlands, where our end product is polyester that can directly be fiber spun again into textiles. Yeah, so we don't make a half fabricate or anything like that. The output that we produce is polyester. Now we got sponsors on board, Coca Cola, but also I think more relevant for today, Adidas. So in fact, we're screening currently the whole catalog of products from Adidas with regards to their composition and how they fit with design for recycling rules that we have for our technology. Very intimate relation. In fact, basically we have every week meetings with Adidas to screen all the newest prototypes they have. And the input we give goes straight to the creation guidelines from Adidas for the new collections. So that's really an interesting collaboration, and I think the way to work. I always say circularity is a team sport. You need to think different from a linear system. And you need to trust also that you can share information to together be successful. We are at the moment very close to deciding which textile feedstock equipment we're going to buy, because in the end we want to basically get actual big bags of clothing and really turn them back into polyester granulate. Yeah, so we can really do that. And that also means that you need to be able to remove metal zippers and all these kind of things. So we are expecting to have that available as of next year. And we're working hard on building our first large-scale commercial plant. It says here 25 kiloton, that's going to be the first stage, but we have enough space for 50 kiloton in Emmen. And we want to keep that first plant and the R&D in one location until we really feel the technology is mature, and then we can go anywhere. In the end, we see ourselves as polyester producers, so we will build our own factories. But to speed up, especially in other continents, we will definitely go for licenses and joint ventures. A lot of requests already, but frankly, we say, let's build that first plant and make sure it works, because otherwise we sell hot air. It doesn't make sense. Better to make it work, and simply disruptive innovation costs time. Our dream is, and I think we will reach that in 2030, that we don't need any fossil resources anymore to make polyester. And you can use bio-based resources or used polyester as a feedstock. Yeah, and we can do both in our plant, because we can also include bio-based monomers into the repolymerization of the polyester. Yeah, so we can check both. Now, luckily, there's quite a few companies in the world working on this theme. I think there's easily 10 to 15 credible initiatives around the world, all with slightly different technologies, and I think they will all find a spot in the market, to be honest. But what makes us a little different from the others, I wouldn't say better, but at least different, our end product is 100% made out of waste. Yeah, so the polyester we make does not contain any fossil resources. Yeah, and that's because we don't make a monomer. We go straight to the final polyester. The other thing is a little bit for people with a chemical engineering background, but our process is a continuous process, which means that our equipment is very small and therefore very cheap to invest in. Yeah, and it's also better to control it. And the third one is very important. With all the technological steps we have done, we have made LCA calculations to make sure we choose the lowest energy consuming route. Because we see that there is a lot of drive to go to highest purity, and then you spend an enormous amount of energy. We're also very happy that we didn't know that up front that it was so important, but we don't use any natural gas. We're quite happy with that. We can do everything with electricity. So that's a lucky... We decided that already 4 years ago, but now it is finally clear why we have to make that choice. Good for the day-to-day bottom line also. The other thing that I think is interesting to mention on the bottom, we are a bit of an unusual startup in the sense that everybody in the management team and the shareholders have at least 30 years experience in polyester. But we still decided to organize it as a startup because we said you cannot do disruptive innovation in a corporate environment. It simply doesn't work. Yeah, so we have a small team, 17 people, and we really run it as a complete separate company, which is, to be honest, a hell of a lot of fun day to day. Important also is we don't only offer chemical recycling. I actually prefer the phrase molecular recycling, to be honest, because chemical still sounds to a lot of people as toxic. In the end, we clean molecules. It's as simple as that, and we all are molecules, whether we like it or not. Yeah? So what we do is not something toxic or funny or strange or dangerous. No, we just clean molecules. But we also offer mechanical recycling. And it's quite likely that for significant streams of textile, also mechanical recycling can be used and is then usually cheaper. Yeah? So why not? Yeah, at the same time, we also give a lot of advice on design for recycling. Yeah? So if you have complex clothing, how could you out-design non-polyester components to make it more recyclable overall? We give a lot of advice on that at the moment. And in fact, that's what we do with Adidas right now. Bottom is also important. A lot of the recyclers look at PET, polyester terephthalate, but that's only one of the polyesters. And especially in textiles, a lot of different polyesters are used. PTT, PBT, copolyesters. In the north, Avantium is now coming with PEF. We can handle all the polyesters at least in one go, so we don't have to sort that out. There's other components which are more difficult, but polyesters, we are happy with that. So that's at least a plus. Now, the big mindset difference maybe that we have compared to others is that we want to make sure that it becomes large scale and affordable. And a lot of the initiatives we've seen have tried to come with reaching virgin polyester quality, but then you are really expensive. Yeah, and you also have hardly an energy gain compared to the virgin process. So we have tried to do it the other way around. How could we do it as cheap as possible, and what is then the purity that we get? And can we then make good fibers out of that? And slowly we will add additional purification methods. We currently have 3 or 4 implemented in our pilot plant, and I think we will end with about 7. And then we can choose, depending on the feedstock quality and on the output quality you want, which of those 7 do you need? It's a bit like going with your car to a washing lane. You can choose which program you choose, so that you can always basically choose the cheapest way to recycle the polyester. Yeah? That does mean, and that's one of the biggest challenges, that you need to know what you put into your factory. So sorting and understanding the quality of your feedstock, I think especially for textile, is one of the largest challenges, because measuring actual chemical composition of textile waste, not so easy yet. But I think that's something we need to work on together to solve that. We work broader than just textile, so we also work on bottles, food and non-food. I would say shampoo and Fanta, let's say, both sides. For us, textile is everything with at least 80% fiber. So that includes consumer apparel, business wear, outdoor, sports goods, but also mattresses, industrial textiles, ropes, filters, paper cloth, machinery, felt, all kind of stuff. The common denominator is that all of them have their own challenges in terms of composition. Yeah? because the polyester is easy to recycle. It's the not polyester part that makes it difficult, let's say. So we have built up relationships usually from the brands down. So we work now with about 350 companies that make these kind of end products. I think with about 150 we have contractual relations, and I think with about 50 we do day-to-day research as we speak. Really trying to understand from their product down to what is in it and how could we recycle it, or how can we change the design so that it is recyclable in the future. Yeah? And of course, yeah, because of that, we've built up a tremendous database around what can you find in products that is not the polyester part. By the way, all these 350 companies told us up front, it's polyester, don't worry, it's easy to recycle. I think it's about one of them that actually had only polyester. That is always something else in there. Some things are easy, some things are difficult. We're currently building up a dashboard where we say, look, with this input specification, we can handle it. And with this, it will be more difficult, or we need more time to develop an additional technology. Yeah, and that's getting closer to a clear picture right now. Now, behind the scenes, there's 3 companies. Kumopol on the left, Custom Made Polymers, is a company in Emmen doing mechanical recycling of bottle flakes, 2 million bottles per day. Dufour, sister company making polyester specialties. Very helpful also, large family-owned company, Moshikov Plastics. Just to give you a feeling, I think the Dufour group is about 100 million turnover, Moshikov Plastics around 400 million turnover. What's helpful for us, one of the shareholders of Moshikov is IKEA, so we have direct access to the key people in IKEA, but also Coca Cola is one of their largest shareholders. So in fact, we have hardly done any marketing, just simply because we know, yeah, the people ourselves, we don't need to have a lot of marketing budget, let's say. And I'm quite happy with that, because we want to be finished first, then we can make a lot of noise. We cover quite a large part of the total cycle, and I think that is quite important for textiles. So there always needs to be some step of collecting and sorting, of course, but as soon as it is, let's say, sorted, we can take it in later, we can take full big bags of actual textile, we can shred that, we can remove the metal, we can compact it, and move it all the way to polyester granulates that are then validated to be able to be spun back into fibers. So if you look at that, if let's say with Adidas, we have a fiber spinner, we have a collection company, and us, we can basically really review the total circularity. And that is extremely helpful, because in a lot of cases, otherwise you need so many players in textile to review whether you really can close the loop, and that is not necessarily making it easier. We have a similar relation in Holland with Auping, for instance, where all the mattresses have been upfront designed for circularity. They take it back, they dismantle it, take the metal out, and we have proven already in our plant that we can recycle that back into new polyester. And with the yarn spinner, we're now validating that it can be spun again back into good yarn, let's say. Quick sort of impression of the pilot plant. Deliberately chosen quite small, capacities between 20 to 30 kilos an hour, 200 to 300 tons a year. And we did that because then we can change equipment very easily. We can throw things out, put new stuff in. But it is run as a factory, so we can run it 24/7 if we want to. And that has been a good decision, because we are still improving day by day, not for research purposes so much, but really to prove the asset utilization rates later of a commercial plant. Yeah, because in the end, this is 1 in 100 from our big scale factory, and we can just simply upscale it very straightforward once this is ready. Building plants in a COVID time is not something I hope to repeat, though. I think in all fairness, we are about 3/4 of a year behind where we would have liked to be due to all these things, but we're not the only one. We would love to be ready already, but we're not. I think we need another 3/4 of a year. We are in Emmen, northeast of the Netherlands. In fact, it's a nice case of reviving old chemical areas. In fact, the industrial park is really coming to life due to recycling. So, frankly, also a nice case of recycling, reusing buildings and factories. That's not unimportant as well. Of course, we have our own lab. This is crucial, because in the end, the whole game is around what's in the polyester feedstock, how do you get it out, what do you have left over at the end, is it safe for humans, is it safe for a new production at the end. So the analytical team is really the beating heart of our team, and they're directly next to the pilot plant. So every trial we do, we directly get the feedback of what is in it, how is it going, and that is really crucial. Now, As said, luckily there are quite a few initiatives, so where do we place ourselves? Mechanical recycling is existing infrastructure, quite successful. I think I would say the polyester bottles is one of the biggest examples of recyclability. In my vision, polyester is such a nice reversible polymer that you can put it in the same space as glass or aluminium. Yeah? As long as we don't put too many other things in it, and it's very simple, it costs you only a third of the energy to recycle it compared to making it out of oil. Yeah? So if we organize ourselves as humanity well, this should be a fantastic carrier for circularity. Yeah? And that's because the chemical bonds are reversible. You can break it down, you can build it back up, and that is only possible with a few polymers. Now, we have the ambition to be the cost leader in the molecular recycling technologies. Yeah? We use a partial glycolysis process, where others have tried a full glycolysis process. And the reason behind it is simply energy. A lot of processes in nature follow an 80-20 process. And that means if you break down polyester for 80%, it only costs you 20% of the energy. The last 20% breaking down costs you 80% of the energy. Yeah? So the curve is like that. We knew that, we found that out, and that's also what we've patented. We could only prove it by building a plant, because you can only do it in a continuous process. You can't prove it in a lab. Yeah? But that's the whole basis that our LCA, our energy use, is much lower than a lot of other processes, where normally people go from, let's say, 100 Lego blocks as a symbol for polyester to 1. We go to 5 to 8, and that saves you 80% of the energy. That was the whole logic behind the technology. A lot of other beautiful technologies out there. Some will have their own spot because they could, for instance, reach a higher purity, but then they are much more expensive. So they will find a spot in the market like hopefully we do. But there will be a range of technologies with different capabilities and different price levels out there. Yeah? We work with most of them, by the way, because we can also repolymerize. So a lot of them go to a monomer, and then they ask us for advice for repolymerization. So we know it's a small world. We know most of them. Here a snapshot of the LCA. One word of caution, this is the screening LCA that we made at the start of our technology development. We are about a month and a half away from having our more finalized LCA that will also be peer reviewed. So the numbers can change a bit. But I would say the general trend is that virgin polyester has a footprint of about 2.2 kilo CO2 for 1 kilo polyester. On the other end of the scale, mechanical recycling is around 0.45. That's proven technology. For textile, we are around 0.5. For packaging, around 0.6. That depends a little bit on the end viscosity, how long you want to make the molecular chain. That depends a bit for textile and for packaging. Now, we're now making the final version. Could be that we end up a little bit higher, but it is, at least if you compare to the other numbers that have been published by players, and we assume that they always put their best numbers forward. It's difficult to compare, but at least if they publish this, I hope that is their most optimistic number. Yeah, we feel quite comfortable that there's really a difference in the technology and a really different level of energy use, let's say. And this helps, of course, because it's almost one-on-one relating to the operational cost you have later and the energy that you use to recycle. Now, the other element is the investment. That's also quite interesting to me what's happening now. Quite a few projects have been announced, which is great. It gives a lot of momentum. None of the factories have been built or run yet, but that's okay. We are in the same league, so I can't say anything about that. But if we simply calculate the depreciation based on the press releases that have been issued, we simply don't understand it. I mean, I've not even the one that is there in France, Eastman announced it, 1 billion euro for a 160 kiloton plant. If you calculate it, it's like 450, 500 euro per ton in terms of depreciation on a product that used to be sold for like 1,400. It's almost impossible to compete with that. Yeah, so we are quite interested to see how this future will develop after all these announcements, because a lot of these announcements are driven by a lot of risk-taking investors that like circularity, that put a lot of money on it. I think what is much more interesting is who will build a second factory, which technology will really be stable after that. And we hope to be at least part of that group. We have to prove it ourselves also. Yeah? But our dream is, as you can see, that even at a low capacity, we can be competitive. Yeah? And our dream is that you don't have to transport waste so far, because that's not really good from your LCA point of view, also from cost point of view. So we would rather build 4 small factories next to big cities so that you don't have to transport your waste so far. And then you can also tailor them in terms of the purification technologies compared to the feedstock that you find over there. Yeah, so our dream is you build circularity into your urban design, and that you really make it a part of how you deal with waste in cities, let's say. That's at least what we try to prove. Yeah, so our dream is to keep this true. These investment numbers are based on our basic engineering, so they're pretty accurate. So we feel quite comfortable with those numbers. And this was post-COVID, so I think we should be quite okay with those investment levels. We hope to announce our big factory end of this year, Q1. That's sort of the time frame that we think we will make the investment decision. Now, this is the last slide. The work we do now is a lot based on closed-loop collaborations with brands. Yeah, because then, for instance, the work with Auping, but also with Adidas, we know exactly what's in the product, we know we can handle it, then you can do efficient recycling. Our dream is to grow that to open-loop recycling, so literally textile, post-consumer textile waste from society, but then we clearly will need to add additional purification steps and have a more robust process. Simply because the sorting techniques are not capable to detect the components that are potentially critical in our process. If you one very simple one, PVC, used for instance on the bottom of carpet tiles, up to 1 ppm level can already make hydrochloric acid in your factory, and it simply corrodes your metal. Yeah, so it's really quite serious. We can't handle that. But if the detection in the sorting is not good enough, we have a problem. Yeah, so we start with closed loop relations. However, the pilot plant will continue to operate next to the demonstration plant, the commercial plant. So we continue to innovate and add additional techniques. And the idea is that in the Emmen factory, we would have ultimately all the different technologies, so that from there we can choose, depending on where we build a plant or with whom we build a plant, we can make the right setup. Having said that, I think that this was the last presentation.
Slide. Wow. Thank you, Josse. Super. We still have time for questions. Any questions in the audience for Josse? Can you stand up for us? Yeah.
Hello, thank you very much for this explanation. I had a question about Adidas. What about your work with them, recycling polyester with the elastane?
Yes. I can't say the exact results because they're under NDA, but I can tell you a lot about elastane. Elastane is a problem, I'll be very honest, for several reasons. But one is the amount is increasing, because after COVID we all didn't like this kind of clothing anymore, but we like more casual clothing. So that's a problem, right? If you look at elastane in clothing, you have it in comfort stretch. That has gone up a lot because of COVID. Yeah? I see my wife and myself several times taking meetings in half pajama outfits, let's say. So that's a problem. Yeah? The elastane content goes up. In the comfort part, you can solve that because you actually have also polyester-based stretch yarns. I think in the higher end performances of polyester, of stretch yarns, that's difficult. Yeah? So you're stuck with polyurethanes. Now, I think it was Albert Einstein who said, I mean, God doesn't gamble. I mean, it's basic chemistry. Urethanes break down in the same process as we use for polyester. Yeah? In fact, urethanes are not that different from polyesters. So what you end up with is that you get a mixture of the building blocks of polyurethane with the building blocks of polyester. And if you then repolymerize, yeah, you get a polymer, but it's sort of half polyurethane, half polyester polymer. It can still be spun into fibers. It's not colorless. So we're now exploring whether that could still be used back into society, back into useful applications. Mind you, 40% of all the clothing is dark at least, so it doesn't have to be a problem. But it's not easy. Yeah? And the biggest problem is you can't detect in your feedstock whether there's elastane in it or not. So I would say within all the things that we want to solve, this is the one where it is least clear how we can come with an economic solution to solve it. So if there's brands in the room and you can avoid elastane in your product, please do so. It's really a nightmare, just down to the basic chemistry.
Indeed, in the sports where it's very difficult to avoid elastane.
Yeah.
Otherwise, you use natural fabrics, but it's not the same.
Natural fabrics are much easier for us because they don't break down in our process. So everything that doesn't break down in our process, we can filter it out. Yeah? So for instance, polyolefins are easy, right? That's not a real problem. So I mean, that's exactly the relation we have with Adidas. So with Adidas, we go through all their products in the Made to Be Remade collection, and we check everything to the last detail. Even we get their suppliers on board to share what is really in it. and we review together with them, does it have an impact on the recycling or not? And that actually is a fantastic relationship. I cannot say anything else. Because it learns them also that it's not so easy, and it's not the recyclers will solve that problem. No, we really need to think together from sorting to design to actual recycling, how we solve that. So we are extremely pleased with that collaboration.
Thank you for that question. Ah, that's close. Here you go.
Hello, I'm Mireille Rijmen from Rijkswaterstaat.
Oh, sorry.
I have a question about the design rules. You were talking
Yes.
about design rules that
Yeah.
you were telling them to the production.
Yeah.
I was wondering, do you have them somewhere online or?
No, not yet, because they're in development.
Mhm.
Because a lot of things we've only tested at lab scale, we want to validate it also at the pilot plant scale. And often they are developed now under NDAs with our partners.
Okay.
So we share them with our partners.
Mhm.
We do want to make them communicatable at some point. But the bottom line is actually we can basically handle everything except elastane. If you want to really make it flat, almost everything else we have a solution for within normal economic boundaries. On the other hand, I do know that the delegation of Rijkswaterstaat is visiting us on October 25, so you can join in, and then we can tell you much more.
Okay, I will. Thank you for
Yep.
your explanation.